Okay. Good evening, participant. Do you have any questions from the last day session? Any questions need to be clarified before we move on to the today's session? Participant, do you have any questions? Any doubts to be clarified? If not, I request you to open a file. In your folder, there is a one Excel file, 1.12 regression. Could you please open? Just one glance, we can go through this data, and then we can move on to this today's session to understand simple linear regression, so that you have more clarity on this. Have you all opened it? Please open the file 1.12 regression in the folder. Dr. Barada shared with you the folder. Say sir, no? Do you have it or not? Anyone please unmute and tell.
Yes, sir.
Okay, please open the file, ma'am. So simple linear regression, you will have one dependent variable, one independent variable. One independent, one dependent. So we are going to predict the dependent variable, the influence of X, or influence of independent variable. So influence of Y, sorry, influence of X variable on Y. We can predict, we can anticipate. So in this Excel file, we are provided with some data like a mile distance travel, the distance travel, and the expenditure, cost involved. Mileage, otherwise miles, and the cost involved. This is in US dollar. So using Excel, how we can understand the simple linear regression? So there are several ways using Excel, the linear regression can be conducted. One graphical way, like similar to Excel, sorry, similar to SPSS, same way. And then there is inbuilt applications also there. We can calculate the slope separately. You can calculate the intercept separately. There is a formula for it. And then there is a formula, there is application called data analysis approach. Wherein when you click the data on your right side, you will see the data analysis. In this approach, in this way also, we can conduct simple linear regression. And then one more is called application is called forecast application. Also, you can conduct simple linear regression. I will explain you two approaches, then we can move on. Okay. A participant, have you all done it? Have you all opened the file? Have you all opened the file?
Sir, excuse me, which file, sir?
The file name is 1.12 Excel file.
Oh. Okay, okay, sir.
1.12 Excel file regression. Can you all see my screen, sir? Otherwise, is it visible to you or not?
Yes, sir.
Okay, the Excel file, is it visible to you? My screen? Can you all see my screen or not? Okay, fine.
Yes, yes, sir.
Okay, okay. So once you have opened the file, you are provided with the two column data, distance and cost. So cost actually is an independent variable. Distance actually is independent variable. Suppose if you travel for 4,000 miles, how much the expenditure will be? Suppose you travel for 1,500 miles, how much the expenditure will be? Suppose you travel only for 526 miles, how much the expenditure will be based on this, the collected data. Agree? Okay. Shall we calculate these measures on your column number D and E? Sorry, column number D, you have been given some measure. Shall we work out and calculate this measure before we move on to compute this equation? Okay. How to calculate the correlation in Excel? In any function, you are going to start in Excel, start with equal sign. Start with 1 minute. Let me increase the size so that easy. Okay. So just put equal sign and type correl, C-O-R-R-E-L. Correl. Excel actually is giving you some condition. some suggestion, you follow accordingly. So when you type equal to choral, it is asking provide your array 1, your x variable, independent variable, and provide your comma, then provide your dependent variable. So this we call them as just enter. This is called correlation, Pearson correlation. Pearson correlation. So it says that your cost is increased, sorry, distance increases, cost also is increasing. That is a positively related. Both are positively related. So how to calculate the R square then? Simple way, if you square this correlation value, you will get the R square value.
Sir,
R square value,
excuse
yes.
me, sir. Sir, instead of correlation, can we write Pearson?
Both can, sir.
Yeah, yes.
Pearson correlation, Pearson correlation, Pearson correlation. Okay, parametric.
Sir, only Pearson will means
No, sir.
serve the purpose, sir. Yes, sir.
No, no, sir. It won't serve the purpose. Pearson correlation coefficient.
No, sir. In the equation, in the formula, sir, if you write equal Pearson, then you can select, then it will serve the purpose, sir.
I didn't get you, sir. 1 minute. There is a Pearson there. Huh?
Yes,
I didn't
sir.
know. I didn't know that. Okay.
Yes, sir.
Okay.
Yes, sir.
Okay. Thank you. I never explored. There is application
Yeah.
Coral also there. Okay. Thanks
Yes,
a lot.
sir. Huh.
Same answer. Same
Okay,
answer.
same answer.
Pearson also there. Coral also there. Anything you can go.
Yeah. Yes.
So how to we can go for? I didn't understand actually. I did understand the first one. Okay. No worry. So how to calculate the R square value? We can also calculate R square value by square the correlation value. This value you can also square it. E4 cap 2, you will get R square value. Please tell me, have you all got the R square value? Have you got the R square value? Please tell me R square value. Yes or no? No one responding.
So we are doing, sir.
Equal to. You can also go for RSQ otherwise. R square value, RSQ. Double click, equal to RSQ, double click. In this, you need to provide your dependent variable or the independent variable. So this is our dependent B2 colon B10 is the dependent variable. And then this is an independent variable, A2 to A10. So this is your R square value, meaning 82.6% of the variance you see in the cost can be explained by the distance. The remaining
Yes,
around
sir.
18% we do not know, some other factors unknown. So R square is meant for how much variance can your independent variable explains the dependent variable. So 82%, the cost it is due to the distance. Okay. Could you also please calculate the mean and mean for X and mean for Y? Shall we calculate the mean?
Yes, sir. We can do
So
it.
mean is nothing but average. So just type average. AVE average X variable. Close the bracket equal to average A2 colon A10.
X
enter.
variable only
A. So then.
Sir, R square can be calculated by doing E square, E4 into E4.
Yeah, possible, ma'am. Yeah, right. You are right.
That
You're right.
can also, I mean, as a
That,
simplified E.
Yeah.
Simplified means, yeah, ma'am, I think that will be the raw technique.
Raw technique. So you can also go for inbuilt function. Like this also
Okay.
possible.
Okay.
This value correlation E4 cap 2 also possible.
Okay.
Cap 2 means square it. You are squaring
Square,
the
yeah.
E4.
Yeah.
E4.
Okay. Yeah.
Okay. So you also can calculate the mean of Y, mean of dependent variable equal to average. When you type equal to average, double click, select this, and then enter. So we have calculated the mean, we have calculated the correlation, we calculated the R square. Shall we calculate for the standard deviation? Standard deviation
Yes,
of
sir.
x, standard deviation of y equal to stdev dot s. The syntax for stdev dot s. stdev dot s. So first one is standard deviation of y, this one. Close the bracket. So B2 colon B10. Standard deviation of x equal to std ev dot s, where x variable, distance A2 colon A10. Enter. So now shall we calculate the A, sorry, this is slope means B. This is for A. Okay. Shall we calculate the A and B? Shall we
Yes,
calculate
sir.
the A and B? So directly
Yes,
also
sir.
can go. Put equal to just slope. Just slope. So understanding the regression using Excel, lot of applications there. Directly you can calculate. So teaching students the concept of regression, Excel will do the purpose. So equal to slope, we need to go for the noun y and the noun x. So select this y variable, comma, select the x variable. Close the bracket, enter. So this is slope. Slope means 1 unit of x increases 1 kilometer. I have given you that in the F column. Intercept. Also need to provide your y variable, comma, the x variable. Participant, do you all follow me? Do you all follow me?
Yes, sir.
Yes, sir.
Okay. So enter. So we calculated A, we calculated a B. We have calculated A and B. So which is needed for our equation. Okay. So now, so this is one way we can calculate, compute this equation and go for a prediction. So we can substitute A value and B value and the X 4,000 mile. We can come to know the expenditure for this. Okay. Shall we work out this? Shall we
Yes,
work out
sir.
this equal to what is A actually? A is intercept this value. A is this value. Otherwise, participant, what do you do? What do you do? Maybe easy. Sorry, put equal to. Put equal to. And before we move on, you also can copy paste this column. Okay, one more time. We are going to use other application. This also you can copy paste here. This particular portion. Prediction 4,000, 1,500, 1,200, 526. Okay. So shall we substitute A value? This is A value. We are going to fix it. Press F4. F4 plus bracket. What is our B value? This is our B value. Press F4. We are fixing the value. Multiply with this. Please tell me, have you all done it? Fixing by dollar symbol. So fixing the absolute value like a B and slope and the intercept. Please tell me, have you all done it?
Yes, sir.
So we can come to know if I drive for 4,000 miles, how much my expenditure will be. Just enter. So it is going to be $959. Suppose if I drive for 1,500, just simply you drag down. So if I drive for 1,500, 460. If I drive for 1,200, will be 400. If I drive for 526, the expenditure will be, cost will be 266. Please tell me, have you all calculated this? If not, I will repeat. Have you all calculated this?
No,
Please tell
sir.
me.
Please repeat it again.
I will repeat. So put equal to, please remember this is an equation, y equal to a plus bx. So y is 4,000. Y is 4,000. We are going to go, sorry. We are going to predict the cost for 4,000 mile expenditure is how much we are going to predict. So this is a value. Otherwise, we also can type the value, meaning 161.388. Also can, you can also key in the value like this, plus put bracket 0.200 multiply with this value A30, close the bracket. So I have substituted a value, I have substituted slope value, and then I have given A13, meaning the 4,000. Just enter and tell me the answer. How much you got it? So you can give the cell reference, or you can give the value of A and B directly to compute the prediction. So shall we make it? Shall we move on?
Yes, sir.
Have you got the answer? 161,388. Slight difference is the right? Is there any slight difference?
Yes.
Is there compared? Some decimal differences is there?
So maybe, yeah, maybe because of the decimal points.
Yeah, decimal differences is there. But have you got the same answer otherwise?
Yes, sir.
So just to drag down. Just to drag down. 161 A plus 0.2 multiply with A13. Okay, fine. So this is one way to calculate. One way to calculate the prediction. Another way, there is an approach, another way using forecast linear. The syntax is forecast linear. Could you please copy the first this thing? Let's copy this and paste it somewhere here. You have X variable, you have Y variable. We are going to predict using forecast application. Shall we do that? Shall we do that? Equal to, sorry, put it in the equal to here. You all follow me? Equal to, just put forecast.
Yes, sir. Yes.
Just put forecast linear. Double click forecast linear. So it is asking you your X and Y. Forecast linear. X is this one. X is this one, comma. Your known Y. This is our known Y. So once you have B2 to B10 you have selected, just click F4 to fix, comma. We can also give known X. This one, this is our independent variable. Press F4, close the bracket, forecast. The same answer you may get. Maybe slight decimal differences will be there. No worry. No worry. Please tell me, have you got the answer? So instead of you calculate the slope and intercept using this forecast linear application, directly you can anticipate. You don't need to remember any formula. Just remember the forecast linear. You'll come to know the answer. Just enter. Slight differences is there. No worry. 959. Due to the decimal differences.
X.
Have you got answer?
Sir, X will be
distance miles,
4,000.
sir. Yeah, X is 4,000, sir. Shall I repeat otherwise? I have asked you to copy paste the table
Yes, sir.
first. Copy paste the table in the G column. Easy. so that you can follow me. Copy paste this table, prediction into the G column, and then you can follow this formula. Shall I repeat otherwise? Shall I repeat otherwise? If you have difficulty?
Got it, sir. Got it, sir.
Got it. So once you are done, simply you drag down for the rest of this thing. So slight differences is there, maybe due to the decimals. Otherwise, we'll go for it. The formula easy, equal to. So please tell me whether you got this answer or not. 959, 460, 400, 266. Anyone? Have you got it? No response. I will repeat otherwise. Don't worry. Shall I repeat? Shall I repeat?
Yes, sir. Please.
Okay. So what you need to do, you copy this prediction value here. I have pasted it in G4. Column number G, row number 4, I have copied, pasted. Put equal to, simply type forecast. And then the fifth menu, when you type 4, F-O-R-E, the fifth menu, the syntax function is forecast linear. Just using your mouse, double click. Forecast linear, double click. In this, Excel is asking you, provide your X value, provide your dependent variable, provide your independent variable. Noun dependent variable, noun X variable or independent variable, automatically the prediction, the cost when you drive for 4,000 kilometers will come to know. So X is this. X is this, comma, and then what is our noun Y variable? This is our noun Y variable. So we are going to go for a flash fill. So we need to fix this value, the reference value. Press F4. In your laptop key, the first row will be F4. Fixing the values, comma,
Yes, sir. Got it, sir. Got it, sir. But we cannot hear you, sir. Are you saying something, sir?
I think Sarah has left. We will wait.
participant, can you all hear me? I have some internet issue.
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Internet issue there. Okay, sorry for it. Most of them using Wi-Fi. Be connected. Go to the Excel file. Can you see my screen now?
Yes, sir.
Yeah. Okay. So have you all used this formula, forecast
Yes,
linear?
sir. And got it, sir.
Okay. Once you have done, simply you drag down. So you can predict 1,500 kilometer, what is expenditure? 1,200 kilometer, what is the cost? 526 kilometer, if you drive, how much will be the cost? Agree? So you can calculate the slope and intercept, and then you can substitute the value one way, or you can go directly the forecast. If you have your dependent variable, you have dependent variable and independent variable. If you have been given your prediction, you can anticipate, you can estimate directly using the forecast linear. So another way to calculate the regression, go to data. Could you please tell me on your right side last one, do you have this data analysis or not?
Yes, sir. But we are to add it, going to add in.
Yeah. So whether you all have it or not? Do you all
Yes,
have
sir.
it? If not, I will explain you how to install it. So with that approach also, you can do a lot of statistical analysis. Do you all have it?
Yes, sir.
No, sir.
Okay. So if you do not have it, if some of you have it, some you do not have it, please go to File. Click on File, the first menu, and then go to the last one option. When you click File, go to File, the last one option. Just click on it. Option.
Yes, sir.
When you click Excel option, you will get this window. In this, click Add-ins. Click Add-ins. Easy.
Add in. Yes,
So
sir.
when you click Add-ins, on your right side, you get some application, Analysis Tool Pack. Analysis Tool Pack. When you get this, just click Go. The bottom, Manage Excel Add-ins. That is a Go. Add-ins. Click Analysis Tool Pack, wherein the particular row will be selected. Row will be blue color. Then click Go. You will get another window like this. Add-ins. You will get these two. The first two you have to check, or first one also if you check, you will get the syntax. The application, data analysis application.
Data analysis.
Yeah. Click Analysis Tool Pack, then click OK.
Data analysis.
Okay. So click OK, so that your data analysis will be activated in your Excel. So once you are done, forever will be present in your system. So the sixth menu.
Sometimes it may not come directly, then we have to restart it.
Okay. If you know how to install it, you can install it. You can add on the application. Okay, no worry. So click on the data. Sixth menu. Click data analysis. Click data analysis. When you click data analysis, a couple of menu has come. Couple of statistical tests has come from the analysis tools, wherein you have to identify the regression. Click OK. Click regression, and you will get this window. Please tell me, have you all got the window?
Yes.
Please tell.
Yes,
so
sir.
in this, you need to give your dependent variable. You need to give your independent variable. So dependent variable cost, independent variable distance. So click on this arrow using your mouse. This time you can select including the value label. Value label. Your header also you can select. Then go to input X range. Click this arrow. Distance miles. Carefully you have to select the cell reference. And then the next one you need to spell out. The first row is my label. The first row is my variable name. So this particular box you need to spell out. And then where do you expect the data output to be displayed? Where do you expect? Are you going to go for the same Excel worksheet, or you are allowing them to have the results in new worksheet or new workbook? Good practice is we can have the results in the same worksheet. So click output range, click this arrow. You can give any cell reference. I expect the value to be this particular cell reference, F21. I'm giving in section. After analysis, provide me the results in this particular location. So what I did, I have selected X variable, I have selected Y variable, labels in the first row, output range I have given. If you want, if you are interested, confidence level also you can give. When you repeat the study for 100 times, 95% of the time your results will be like this. Maybe the previous class, the last week class also, we discussed about the confidence level. So further, so these are the options available in Excel. So once you've done this, click OK. So whatever we calculated, this is your Pearson correlation. By the way, please tell me whether you got answer or not. This is your R square. And there are 9 observations. The model is significant. The model is significant. And this is
Sir, what we have to put in an output range? Can you please repeat?
Anywhere you can choose, ma'am.
Okay.
Anywhere in the Excel sheet. 1 minute, I'll repeat. So if you can't follow, if you can stop me immediately. That will be easy. Okay, fine. So I will repeat the steps again. Participant, please go to data. We have a long way to go. Click data analysis. Data analysis, regression. In this menu, click OK. So here what I have done, in this icon I have chosen cast is as an input Y range. I click on this arrow. Click on this arrow. I have selected this. Input for X range. This value we need to select. And then labels in the first row. Check box this. Click this label. Confidence level. And then output range. Click this output range. Click on this arrow. You select any particular cell. So I have selected F21.
Okay, sir.
I have given F21. You can choose anywhere. The particular location output will be present. The Excel will give you the output. Any cell, any empty cell you can select. So I have chosen F21. That's it. Click OK. Your output will be ready. So we calculated the correlation 0.909. This is the correlation. This is actually R square value. We calculated 826. 826. And then this is what we calculated. This is what you call A and this is B. Intercept and slope 0.20. When you reduce this value, please tell me, have you got it? Have you got it? Same value?
Yes, sir. Yes, sir.
So with this also you can go for substituting using the equation y equal to a plus bx. You can predict any unknown x, predicting the y, predicting the dependent. Okay. So I hope you all would have understood the linear regression very nicely. The concept of linear regression prediction. So several approaches I have taught you. Shall we move on to today's session? I think we have taken more time. So once you are done for simple linear regression, you can also run the multiple regression very easily. So what do you mean by multiple regression? What do you mean multiple regression? Multiple regression means you have one dependent variable, you will have several independent variables. So effect of several independent variable on your dependent variable is multiple regression. Can you all see my screen? Can you all see my screen?
Yes.
So
sir.
multiple regression is an multiple regression. Thank you. Multiple regression is an extension of simple linear regression. It is used when we want to predict the value of variable based on the value of two or more other independent variable. We can predict a value of a dependent variable based on the value of two or more other independent variable. The variable we want to predict, we call them as a dependent variable, or sometimes the outcome variable. We can call them as a target variable, or we can also call them as a criterion variable. Why? So this is dependent variable. So the variable we are using to predict the value of the dependent variable, we call them as an independent variable. Otherwise, we can call them as a predictor variable or explanatory variable. So, for example, multiple regression. Exam performance of a student can be predicted based on how much time the student spent for it. Revision time, the student's test anxiety, the number of hours he sat for the exam, and then is there any difference between male and female? So exam performance can be predicted based on number of hours the student sat for the exam, anxiety of the student, the number of hours he sat for the classes, and the gender also we can predict. Similarly, daily cigarette consumption can be predicted based on the smoking duration, age of the student, when the candidate started, the smoker type, income, gender. So any quantity of your dependent variable can be predicted with several independent variables. Simple example I given you.
Sir, one independent variable may be the peer pressure.
Yeah, also possible, sir. Any independent variable you can have it.
Okay.
In any independent, several independent variable you can put in. So simple linear regression, you have one independent, one dependent. Multiple regression, you have one dependent, continuous, whereas independent, several independent variable. So multiple regression also allow us to determine overall fit of the model and the relative contribution of each of the predictor to the total variance explained. How each variable, how much age influences, how much the number of hours the student sat for the exam, the performance influences. How much otherwise the revision time, and then anxiety, and the gender, each variable we can also come to know the influence or the variance. Each variable, how much it influences. So for example, you might want to know how much of the variation in exam performance can be explained by the revision time, test anxiety, the lecture attendance, and the gender as a whole. But also the relative contribution of each independent variable in explaining the variance in the dependent variable. We can predict. Agree? Shall we move on? So linear regression is used for three main purposes. Used to assess how much each independent variable contribute in determining the value of the dependent variable. How each independent variable contribute in determining the value of the dependent variable. And what direction the relationship. One variable increases, other variable increasing, whether positively influencing or negatively influencing. Whether increases, whether it is decreases. They contribute. The relative importance in deciding the value of the dependent variable we can come to know. So the R square and F significance determine the reliability and validity of the model. Reliability and validity of the model. So while conducting multiple linear regression, I will explain the importance of R square and the significance. So what are the assumptions? The assumptions are similar with the simple linear regression. Your dependent variable should be measured on a continuous scale, can be ratio or can be interval. Ratio scale or interval scale, any numeric. So then next one, you should have two or more independent variable to run the multiple regression. This can be continuous or this can be categorical, like ordinal or interval, nominal also, ordinal or nominal. Scale also can be included. Ordinal means any kind of Likert scale. Nominal means any kind of category, smoking, not smoking, married, not married. And then what do you call male and female. Nominal scale also can be included. So there should be linear relationship between the dependent variable and each of your independent variable, especially independent variable collectively. And then the data should not show multicollinearity, meaning your independent variable should not show highly correlated. So which occurs when two or more independent variables that are highly correlated. So this multicollinearity will affect your analysis. Multicollinearity will influence your analysis. Your independent variable should not be highly correlated. And the last assumption, there should not be any significant outlier. Highly influential, highly extreme value. That should not be.
Sir.
So, yep.
Excuse me, sir. If
Yes,
multicollinearity is present there, then what should be the step, sir?
If multicollinearity means we have to remove the particular variable for analysis.
Okay, sir.
We need to remove the any variable. We need to remove.
Yeah. Okay. Sir.
Okay. So yeah.
Sir, if we have one independent variable and there are 4 or 5 dependent variables, can we run regression on that also?
Definitely no. Definitely no. You can go for multivariate analysis of variance, ma'am. MANOVA.
Okay, ANOVA. All right.
You can MANOVA, multivariate analysis of variance.
Okay.
MANOVA, multivariate. Okay. You have one independent, several dependent means you can go for MANOVA.
Okay.
Yeah, likewise father of the house and all other dependent dependent members.
Okay.
Yeah.
Okay.
Okay, right. So I'll give you one simple example to understand the multiple regression. One healthcare researcher wants to predict the VO to max. Yesterday also the same example we used. VO to max means is an indicator, fitness, how much a particular candidate, otherwise the maximum volume of oxygen that individual can use it for a given time. So this can be measured in ml per kg per minute. How much the candidate, milliliters per kilogram body weight per minute, the oxygen can be, the candidate use it, maximum volume. Just some entity. A majority of the participants are business background. Just remember, VO to max actually one numeric ratio scale dependent variable. We are going to predict. So it is possible to predict an individual VO to max based on attributes that can be measured more easily and cheaply. So measuring the VO to max instrumental. So can we predict every time instead of using this VO to max by having the machine? Suppose if you have age, weight, heart rate, and gender, we can predict how much the candidate will be. He can have this VO to max test. So a researcher recruited 100 participants and measured the VO to max test. And also they recorded age, weight, heart rate, and gender. There are 4 independent variables. And VO to max, the result is the dependent variable. So the researcher goal or objective is to predict the VO to max based on the 4 attributes like age, weight of the candidate, heart rate, and gender. How age influences the VO to max, how weight influences VO to max, how heart rate influences the VO to max, how gender influences the VO to max. So in SPSS, we need to enter all your data. Age in one column, heart rate in one column, weight in another column, gender in another column, the dependent variable in the last column. Understood? So this is where you need to enter your variable. So some are numeric, some are categorical, some are qualitative. Gender is a qualitative. Remaining all numeric. So once you have entered the data in SPSS, we need to go to analyze, go to regression, wherein you need to select linear. Just I'm demonstrating, later on we work together. Just I'm explaining the steps. Please remember. So once you key in the data, go to analyze, regression, linear. You will get this window similar to simple linear regression. So place your VO to max in the dependent. Remaining all your independent variable, you place it in the independent. So transfer the dependent variable VO to max and the dependent, and the independent variable age, weight, heart rate, and gender into the dependent. All right. The next steps, click statistics. We need to click statistics. You will get this window wherein you click estimates, confidence interval, and model fit. And you also can click collinearity diagnostics, multicollinearity, right? We can also go for collinearity diagnostics. And then continue. Click OK. You will get the output. This is a model summary. You will get the multiple correlation. This is R square value. This is adjusted R square. Yesterday, somebody asked me when to use adjusted R square. When you have multiple independent variable, you can use R square and also along with adjusted R square, nullifying the predictors, too many variables. Adjusted R square is advisable. So R column represent the R value, meaning multiple correlation. R square represent R square value, which is the proportional variance in the dependent variable that can be explained by the all independent variables like gender, age, heart rate, weight together explain the VO2 max by 57.7%. So independent variable explain 57.7% of the variability of our what you call the VO2 max, the dependent variable. And then next table, you be given with ANOVA. ANOVA, this particular column should be significant. The P should be less than 0.05. When it is less than 0.05, meaning your independent variable statistically significantly used to predict the dependent variable. Meaning your independent variable, gender, age, heart rate, weight influences the VO2 max. So the model is a very fit. The model is good for prediction. The model is good for anticipation. The model is very good for conducting regression analysis. So next table, you will get this coefficient table.
Excuse me, sir.
Yeah.
What's
Yes,
the
sir.
value, sir?
Second, sir.
Interpretation for F value.
F value actually is ANOVA.
2.393.
This one, sir. This is actually is ANOVA table, sir. Higher the F value, the model is significant. Higher the F value.
Is there any limit? Is there any interval, sir? That the F value should be within that interval or not?
No such, sir. No such. Normally we refer the last column sig value, the P value only. Normally we look at, but this F value just we mention.
Okay, sir.
F value just we need
Thank
to
you,
mention in the result section. We don't need to worry about the F value. We mention this
Sir,
P value.
sir, may I interfere?
Yeah.
Yeah, say F, this F is the ratio between these two mean squares, this 1049.121 and 32.387. And to verify these things, yeah, our test statistic is F, and this is the value of the test statistic only.
F statistic, yes, test statistics. Yeah, you're right.
Yeah,
the mean
yes,
square
yes,
divided by the residue.
Ratio between the two mean squares.
Yes, yeah, ratio between the two mean square. So we do get the mean square from the sum of square. 4196 divided by degrees of freedom 4, you will get 1049, sir. The residual 3076.77 divided by 95, you will get 32. So F ratio can be calculated from the mean square, like ANOVA, within group and between group. Okay, yeah. So the next one, you may get the coefficient table. From this, we can go for a equation predicting the VO2 max. So this is a constant, and this is your unstandardized what you call coefficient. Age. So 1 year age increases, this much VO2 reduces. Negative meaning reduces. 1 kg body weight increases, the VO2 max, this much unit decreases. So 1 unit of heart rate increases, this much unit or decreases. And this is for gender, male. Okay, so we can predict the VO2 max by having this equation. So constant, then you can add on this value and substitute with the age. For example, someone age is 25 years old, his body weight is 75, his heart rate is 130, and he is a male. How much the VO2 max the candidate will have? We can predict. So you can substitute the age, you can substitute the weight, you can substitute the gender, you come to know the VO2 max of the particular candidate approximately. So unstandardized coefficient indicate how much the dependent variable varies with an independent variable when all other independent variables are held constant. Consider the effect of age in this example. So the unstandardized coefficient for age is equal to negative 0.165, meaning 1 year age increases. There is a decrease in VO2 max of this much. 1 year age increases, this much unit of VO2 max decreases due to the negative sign. So the standardized coefficient, this one, this column, the standardized coefficient indicate which independent variable contribute to the maximum. Please tell me which the beta coefficient, which variable contribute most actually.
Gender.
We can rank.
Gender,
So
gender, sir.
Gender. Age comes followed by the weight, heart rate, and so on. Okay. Yeah. So writing the report, we need to write like this. A multiple regression analysis was conducted using SPSS version 25 to predict the VO to max from the independent variables such as gender, age, weight, heart rate. The variables are statistically significantly predicted the VO to max. We can write from the ANOVA table F4 and the numerator denominator equal to the F value, we can capture it here. P less than 0.05. R square value you can spell out. And all four variables added significantly to the prediction, and P less than 0.05. All the variables. All the four variables significantly predicted the equation. And you can also give the equation. This equation. So multiple regression very, very easily can be exhibited in a research paper. Shall we go for it? Shall we go for it? I have two examples. We are going to run the multiple regression. Shall we go for it? Please open the file and go to the folder.
Sir, it is 2.4, sir.
2.4. Yeah, okay. 2.4. Yeah, correct. 2.4. Open the file. 2.4. Have you opened it? So the data were collected from 100 candidate. So this is the age, heart rate, weight, gender, and VO to max. So always a good practice is when you have such numeric data and categorical data, we need to have some kind of descriptive statistics. Yes or no? We need to have some descriptive statistics before we move on any kind of analysis. Shall we run the descriptive statistics?
Yes, sir.
How do we run the descriptive statistics? Go to analyze. Descriptive statistics. Descriptive.
All variables.
Except the gender, except the categorical, except case number and gender, you can transfer it. Gender is a categorical, so we can go using frequency analysis. So click option. I'm interested only mean and standard deviation. I'm interested only mean and standard deviation. Enough. Continue, and then click OK. So this is my descriptive for explaining each variable. There are 100 candidates. The mean is 31. Standard deviation is 8. Heart rate of the participant 126 plus or minus 14 standard deviation. Weight 72 on average plus or minus 15 kg. VO to max 44 plus or minus 14. And then I also need how many male and how many female. How do I go? Go to analyze, descriptive statistics, frequencies. So transfer the gender here. You can also go for a chart, pie chart this time. Continue. Click OK. I think the first day we have done it. So you come to know how much percentage are male, how much percentage are female. So while writing the results, you elaborate. The study consists of this many male, this much female. The average age was found to be this. Heart rate is this. Weight of the participant is this. VO to max is this. So multiple linear regression was conducted using SPSS version 25 or 26. whatever the version you have. Give me a minute. My system is running. So 43% are female, 57 are male. Have you all got it? Have you all got it?
Yes, sir. Yes, sir.
Okay. Okay. So understood, 43% are female, 57% are male respondents. Okay. So these all data can be captured in your result section. Then we can go for a multiple linear regression. Go to analyze. Go to analyze. Regression. Then linear. Analyze, regression, linear. Analyze, regression, linear. Click on it. Click on it. Have you all done it? Do you all have this window? Do you all have this window?
Yes,
or
sir.
no? So
Yes, sir.
transfer your, yeah, thank you. Transfer your view to max, except the case number. By pressing the shift key, transfer all your independent variable in this window. So we go to max and independent, all the independent variable. So click statistics. Click statistics, confidence interval can be chosen. The collinearity diagnostic can be chosen. So one of the assumption, multi-collinearity can be tested using this collinearity diagnostics. Have you all done? Have you all done?
Yes, yes, sir.
So once you're done, continue, then click OK. Continue, then click OK. You will get a simple output. So the first table actually is a model summary. R equal to, this is R is nothing but the multiple correlation. Independent variable on dependent variable, the relationship is 95%, 95.4. And R square is 90.9, meaning
Square of R.
the square of R value, meaning 90.9% of the variance you see in the VO2 max can be collectively influenced by or explained by the 4 independent variable. So this independent variable explain your dependent variable 90.9%. Remaining 9% maybe some other factor. We do not know, which is very good. Which is very good. R square value, and then ANOVA. It says that ANOVA, the p-value is significant. The p-value which is significant, meaning the model is good for prediction. The model is good for the prediction. Okay, the model is good for prediction. So look at here, the coefficient table. The coefficient table. We need to see whether all the variables are significantly influencing or not. In this, actually the data which is I have presented in the PowerPoint and this slight difference is there. I missed the file name. Look at here. So all these variables are significant. Age also significantly influences. Heart rate also significantly influences. Weight of the participant also significantly influences, but gender do not.
Yeah.
Gender do not significantly. Maybe gender you can remove from this running the multiple regression. So cannot, gender do not say that male and female there is a differences in terms of VO2 max. So collinearity diagnosis. The index, something's wrong. Yeah, this one. So this, the variance inflation, the last column should be less than 5. Should be less than 5. So it indicates there is no multicollinearity, meaning all your independent variable do not relate each other. It's well and good. Anything less than 5 is well and good. Variance inflation factor. Is that fine?
Yes, sir.
So tolerance should be less than 1. Tolerance should be less than 1. So
once again, repeat it once again.
Which one, ma'am?
Yeah, the tolerance.
Yeah, tolerance and variance inflation factor means when your variables are highly correlated, your independent variable are highly correlated, the variance inflation factor will be greater than 5. So the cutoff point, the variance inflation factor less than 5, consider there is no any multi-collinearity issue. Your independent variable not highly correlated. This is what we expected. This is what one of the assumption. So the assumption is fulfilled. So there is no any multi-collinearity issue. Your independent variable is not highly correlated with each other. But independent variable are related with dependent, well and good. All your independent variable not related with, highly not correlated. So based on these two issues, we can discuss multi-collinearity. Is that fine?
Yes,
Is that
sir.
fine? So we can predict this equation. Copy this table. Copy this table.
Sir, excuse me, sir. What about tolerance? You were talking about tolerance?
A tolerance should be less than 1, sir.
Less than 1.
Less than 1. The limit is less than 1. These two meant for testing the assumption of multi-collinearity. Testing the assumption of multi-collinearity. Tolerance level, the cutoff point is less than 1, whereas the variance inflation factor, VIF value, should be less than 5. Okay. So copy this value, coefficient table. Shall we run without gender? The gender is not influencing. And one more time. So gender we can remove and run the analysis. Shall we?
Yes, sir.
Then that will be prediction will be nice. Okay, go to analyze now. Go to analyze. Regression, linear. You remove the gender. Remove the gender, rest everything you leave it. Okay, click OK. Let us see how it is now. Slightly the regression difference is there. The model is significant. The variance inflation factor within the limit. And this is what the regression coefficient. Shall we run? Shall we compute the prediction? Have you all got the answer? Have you all got the answer?
Yes, sir.
So copy the coefficient table. Copy this. Open an Excel file. Wherein you paste it.
Sir, but in my data, it is showing some other figures. The weight of the participants, it's showing 0.440. I mean, before also, is there any change in the data as well on which you are running?
Is it, ma'am? I don't know whether the same data only I'm using. You all have the same results or different results?
Different
Same,
results.
Same
I'm
results
getting, sir, it is 2.4 we are running, no?
Sir, will you show yours?
Yeah,
yes,
I can.
2.4. This is mine. Yeah, I will show my results. Second time I conducted.
Sir, first I conducted with a gender. It is, it is gender. It is coming 0.000 and weight is coming 0.685 and heart rate is 0.004.
Oh, okay, maybe I think I sent you some different file. I think how about others?
I don't know.
But
Maybe.
sir, we got the same file. I think we got the same result, sir.
I think, sir, there is some.
Yeah, maybe
some clerical.
Ma'am, otherwise you might have chosen some other file, ma'am. The first day I sent you the that folder you might have chosen.
No. This
same folder, yes.
Yes, same folder. Yes, yesterday. It's
okay.
Anyway,
no worry.
Sir,
anyway, you got the answer right. Anyway, you got the answer right.
Yeah, I got it. But I was really wondering because the numbers, the figures are different. What you are explaining.
Okay. Little bit I changed actually. Oh, no worry. So copy this coefficient table. Yeah, copy this coefficient table.
Okay.
The last one. Coefficient table. And you paste it here. You paste it here. So this is A1, this is A2, one minute participant, have a call. Sorry, participant. Sorry, I got a call. Okay, have you all copied the table? Have you all copied this? This is A3, your independent
Yes, sir.
variable. So imagine that X1, this is a age, and then next one is a heart rate X2, independent variable, and weight X3. So we are going to predict VO to max. VO to max, otherwise Y. So what is the how do you write the equation? A plus BX, right? So A1 multiply with age plus, otherwise we can also write X1 age, X1 age, and just explaining the formula for you to understand, plus A2 multiply with X2 heart rate plus A3 multiply with X3. X3 means weight. So participant, can you all hear me? Participant, can you all hear me?
Yes.
Okay.
Yes, sir.
Yes, sir. Voice is audible.
Yeah. Okay. So now this is what we got it. This is the value. You can paste it here. This is your coefficient. You also can go for A1, A2, A3. Let's say So this is age, this is heart rate, this is actually weight. Suppose someone, his age is, let's say, imagine that age is 45. Heart rate is 120, 25, imagine that. Weight is 75 kg. Shall we substitute this equation? Shall we substitute this equation? Shall we create the equation? Please tell me. Someone age is 45, his heart rate is 125, his weight is 75. How much the VO2 max will be? How do you work out? How do you work out? Equal to this value multiply with this value. Select all this, drag down. Now you can sum off all this. Sum all this. You'll come to know the candidate VO2 max. Please tell me what is the answer. Please tell me what is the answer. Sorry, we need to add the, sorry, 1 minute. We need to add the constant also. Constant we need to capture. This constant we need to capture. Equal to this value plus this plus this plus this. That's it. Tell me the answer. Tell me the answer. Tell me the answer. How much it is? Anyone tell me the answer? Hello? No response? No response. What is the answer for it? Hello? Any difficulty for computing this? So the VO2 max will be 31. Shall I repeat otherwise? Participant keeping silent. I don't know whether you all understood or not.
So we are still doing it.
They still doing. Okay, I will like whether I went fast. Otherwise, shall I repeat otherwise? Please tell me. Accordingly, I'll go.
Yes, sir. Repeat, sir.
Okay. So first of all, you copy paste this from the table. You copy paste this simply. Age, heart rate, weight. This is the prediction we are going to go. Prediction. We have the constant. We have the what you call unstandardized coefficient. And you have one candidate. His age is 45. His heart rate is 125. Body weight is 75. How much the VO2 max the candidate will have?
So in prediction, whatever we are taking the figure, sir, that is our assumption only. Eh?
Assumption, yeah, assumption, sir. Yeah.
Okay. Okay.
So anticipation. So to do this, we are going to use this formula. We are using this formula. I think slight modification is needed. When I put this formula, it won't take it. This one maybe. Okay. Otherwise, leave it. The formula is leave it. It is there in your. It is there. In this equation. Yeah, this is equation. It is there. It is there. So intercept plus we need to add on the value. Okay. No worry. Sometimes Excel also. So to do this, first we need to compute these two function. this value multiply with this value, you'll get, and then simply you drag down. So age we calculated, heart rate with the prediction we calculated, weight of the candidate, and the what you call the unstandardized coefficient we predicted. Now we can sum off all this.
Sir, excuse me, sir. These predictions are the assumed values only, 45, 125, and 75.
Yeah, assumed value, sir.
Okay.
This is actually someone for an unknown. We go to max, we do not know, but we know his age, we know his heart rate, we know his weight. But using this equation, we can anticipate, we can predict how much will be. The dependent variable we can predict. We have, based on his candidate, the data, age he has given, heart rate he has given, weight has been given, but we do not know his VO2 max. So we are going to predict. Is that okay? We are predicting from this 3 independent variable. Now, shall we calculate equal to this value plus this plus this plus this? We'll come to know how much his VO2 max will be. How much his VO2 max will be. Just enter. So he will have 31 ml per kg per minute, the VO2 max for this candidate. Sir. For this candidate, yeah. So I'll give you one more example. I will ask you to run. Whether you all get the same answer or not, you need to tell me. Please go to the folder wherein 2.1 multiple regression, family size, income versus expenditure. Simple example. Open the file.
Sir, whatever we got the result, that is 31 ml. So that means we have quantified.
Yeah, quantifying the VO2 max.
Oh, okay.
Okay. Suppose maybe you can go to the Excel files. Again, I will modify this value. For example, his candidate, his weight is what do you call it? His age is 50 years. His heart rate is 130. Just I am modifying the value. His body weight is 60 kg. How much his VO2 max will be? This is what the value is, 29.
29.34.
For example, someone age is 25 means?
So what does it mean? Yes. Sir, tell me.
If I modify the independent variable, accordingly the VO2 capacity is increased. Younger one will have more capacity, more VO2 max. Agree, sir?
Yes, sir.
Agree? So
yes.
When you modify your independent variable, your outcome variable also, that what you call also will be modified, will be influenced. Depends upon the unstandardized coefficient and the independent variable, unknown values. Okay.
So
understood, sir?
Is there any role of the value here, sir? That if it is the value is more, so
which one, sir? Which one you are talking about, sir?
Whatever we are quantifying, sometimes it comes 31, 29 or 55, whatever. So is there any role of this value?
Yes, sir. That's what 1 unit of age increases, sir. I am telling 1 unit of age increases, this much VO2 volume decreases. 1 unit of heart rate increases, this much unit of VO2 max reduces. 1 year of 1 kg body weight increases, this much unit of VO2 max decreases. That is what the negative symbol, the unstandardized coefficient, negative symbol. Agree? Agree, sir?
Yes,
sir.
Okay. So another example, maybe that will be relevant, that will be easy for you to understand the concept. So you are provided with, there are 20 family. The data were collected. What are the data were collected? How much you do spend for your house? What is your income? What is your income? Maybe you can go for this is in 1000. This is in 1000. The income is in 1000. And another size, family members. Family size is a member. So income influences expenditure. Family size, the number of family members in a family influences expenditure. So these two will influences the expenditure in a family. Is that, do you agree with me?
Yeah, yes, sir.
So if any family, if they have more income, the expenditure also they spend more. Not 100%, maybe it's around 60 to 70%. If they get more income, they spend lavishly. Family size increases, they cannot control the expenses. So there are some family got 3 members, some got 3, some got 4, some got 1, and this is the expenditure. So suppose you have one of your friend, his income is 25,000, and there are 6 members. How much the family will spend for? We can anticipate, we can predict. So dependent variable expenditure, independent variable income, and family size. Agree with me? You agree with me?
Yeah, yes, sir.
So now shall we run? Shall we run?
Yeah.
Shall we run? So after this, I will give you 5 minutes break. Go to analyze.
Descriptive.
Descriptive also you can run. Yeah, better. Go to analyze descriptive. You will have some idea. Go to analyze descriptive. You transfer all of them. Option. Minimum, maximum is not needed. Mean and standard deviation is enough. Continue. Continue. Click OK. So you have a simple output. So annual food expenditure, this much in $1,000. And annual income, this also in dollar. Family size around 2.95, an average. So this is a descriptive statistics. Shall we run the multiple regression? Shall we run the multiple regression?
Done, sir. Done, sir.
Oh, fantastic. Very fast. Go to analyze, regression, linear. So expenditure is we are going to predict the expenditure. We are going to predict the expenditure from income and family size. So annual income and family size should go into the independent.
Okay, sir. I did a mistake. I took family also.
No. So independent variable, income and family size, how does influences expenditure?
Doing it, sir.
So increasing family size, increasing expenditure, increasing income. Is there any relationship with expenditure?
Yes, sir. Done, sir.
So we can predict. So click statistics, confidence, collinearity diagnostics. Continue, then click OK. Continue, click OK. You will get a table.
Sir, can I ask one question, sir? Yeah.
Please, sir.
Sir, in this case, we have taken 2 independent variable and 1 dependent variable.
Yeah, right.
So yesterday we also took the same variables, one dependent variable and 2 independent variable, but we analyze with different methods.
No, sir. We did not take 2 independent, sir. Which statistical test we took?
Maybe I'm confused.
Actually, no. We need to know the objective of your study, sir. First of all, what is your objective? What is the objective, and for that, what statistical test will be relevant? So this particular question, you are provided with 3 numeric variable. You are going to study the relationship. You are going to predict.
Told in the correlation, perhaps not the regression.
Correlation we go. Sorry. Correlation we gone for partial correlation, sir.
Partial correlation, right?
Partial correlation. Partial correlation meant for the relationship, sir. So regression is meant for prediction.
Yes, sir. Yes. Okay. Go on.
We can model it. We are going to do the model.
Thank you, sir.
Yeah. Okay. So the interpretation I have given in the results, the model summary, you got it. So your family size and annual income related with expenditure is highly significant, meaning highly related, 0.967. R square value, meaning 93% of the expenditure, the variance of expenditure can be explained by the size and annual income. The remaining 6.5%, we do not know some other factor. Agree with me?
Yes, sir.
Agree with me? So some other factors. So 93%, the variance you see in the expenditure, only these two factors. What are the factor? Family size and their income. And then there is another way. The children's age also, there is a matter. Someone family, the children are very, 18 years plus. If they go to any universities, the expenditure will be high. That also matter. So family members also, there is a matter for expenditure. So the model is significant. The model is significant. It says that P is less than 0.05. The model is very good, meaning your predictor variable, your independent variable, family size and annual income significantly influences the family expenditure, food expenditure, right? So see here, the unstandardized coefficient, both are significant. Annual income also influences expenditure. Family size also significantly influences expenditure. Look at here, which one is highly significant? Which one influences more?
Family size.
Family size. Sorry, based on the beta coefficient, standardized coefficient.
Okay, sir. Yeah.
Based
so
on the standardized coefficient, income is more, followed by the. So this will tell us, the standardized beta coefficient will tell us which independent variable contribute more.
Okay, sir.
So income contributes more, followed by the family size. But the unstandardized coefficient can be used for prediction. Unstandardized coefficient can be used for prediction, meaning $1 increases in their income. This much unit, the expenditure will increase in the family. Otherwise, one family member increases in the family. This much expenses will increase. This much unit of expenses will increase in their family. Agree? Agree?
Yes, sir.
And then look at the variance inflation factor. Variance inflation factor less than 5, well and good.
Yeah.
So annual income and family size not highly related. So there is no any multicollinearity issue. The assumption has been fulfilled. And how do we write these results in the inference? So I have given you step by step. I have given you the example. So dependent variable family expenditure, independent variable family income, and family size. So dependent variable family expenditure, we call them as a Y, family income X1, family size X2. So I got the model, R value this, R square value this, F value, this is the F value, and P less than 0.001. Highly significant interpretation. So in a nutshell, we need to write in the result section. Result section, we need to write multiple regression analysis was conducted to study the significant relationship between family size and annual income on the expenditure. The results reveal that the multiple correlation coefficient is equal to this. It measures the degree of relationship between the actual values and the predicted value of family expenditure. So the coefficient of determination of R value, R square, is 0.935. Simply meaning 93.5% of the variance or variation in family expenditure is explained by the family income and family size. These are the independent variable. So R square value, which is significant at even less than 1% level of significance. 1% level of significance. And then based on this, we can run the equation. So multiple regression. This is actually the A, this is B1 and this is B2. This is A intercept, this is B1 and this is B2. So if you substitute someone family income, someone family size, we can anticipate how much expenditure will be. So coefficient X1 is 0.148. This is represent the partial effect of family annual income on the family expenditure, holding the other variable as a constant. So estimated sign indicate positive sign implies such effect is positive. So income increases, expenditure also increasing positively. So X2 is 0.793. This represents partial effect of family size on the expenditure. So estimated positive sign implies that such effect is positive, that family expenditure would increase by 1 unit of your family size increases, this much expenditure will increase in the family. Now, shall we calculate the family expenditure? What do you need to do? Go to Excel. Sorry, go to SPSS. Copy this coefficient table. Copy this coefficient table. Go to Excel. Paste here. Paste it here. Copy this and summary paste it here. Easy. Similarly, so someone you have your someone, one of your friend, imagine that, or otherwise your income or your family size, you can keep it. Based on that, approximately how much your expenditure will be, we can anticipate from this equation. Yes or no? Shall we predict? Imagine that your family. Just we put prediction. So maybe your annual income, maybe not annual income, sorry, monthly income. Imagine that, sorry, annual income. Imagine that 40,000 US dollar. Just put 40. The same unit we need to put in this data. Our data original unit presented in 1 minute. Presented in dollar. Income in $1,000. Okay, the same unit we need to put. Please remember. So the data presented in dollar. Okay. So $40,000. Imagine that your income, annual income. Your family size is 5 members. So based on this unstandardized coefficient, how much your expenditure will be, we can anticipate. Please tell me. Anyone, please calculate and tell me. Annual income $40,000. Your family has got 5 members. How much the expenditure will be? Anyone, could you please tell me the answer? First of all, we need to multiply this. This multiply with this. Drag down. Now we can add on the value. This value plus this value plus this value. So we come to know the expenditure of this particular family. Your income is a $40,000. Family size of 5. This much will be this much $1,000 you may spend for it from your income based on this hypothetical data. This much $1,000. So 1 unit increases. Participant, have you all got the answer? Have you all got the answer? Anyone? Please tell me. Boring today? I think yesterday class somewhat interesting. Today I couldn't much into on this and your response. Whether will you able to follow? Could you follow?
40 and 5. Okay, sir. I'm doing, sir. Sir,
Yeah.
we lost the connection, sir. That's why, yeah, we are
okay.
little bit delayed.
Connection from my side or your side, sir?
No, from our side, sir.
Okay, fine. Please tell me the answer, whether you all got it.
Yes, sir. Answer, sir.
So someone family is a 40,000 income and the family size 5, their anticipated expenditure will be $8,000. Suppose 41,000, 6 members, their expenditure will be $9,000. $41, and if it is 6, the expenditure will be this. So if you modify your independent variable, your X variable, automatically this also will increase or decrease. So please remember, 1 unit of annual income increases, this much unit expenditure will increase. 1 unit of family size increases, this much $1,000 will increase. This much unit of your expenditure also will increase. Please tell me. Please tell me. So what is the total of these two? Equal to this and this. So 0.94. So 41.6, this much expenditure. Maybe I'll copy this and paste it here. So another one, I will, this is 41 and 6 size, family size. Suppose if I change it for 40 and 5, this is for the family of 40 and 5 family size. What is the difference between these two? How much difference is there? This value minus this value, you will come to know the difference. Can you see the differences of these two? This and this, are they same?
Yes, sir.
This and this, are they same? So please understand, 1 unit of your independent variable increases, this much the standardized coefficient unit will increase in the family. So this and this are same. That is what I wanted to highlight. So participant will go for a 5 minutes break, short break, then you come back. We will do the logistic regression. Okay. Okay. 5 minutes break.
Sir.
Say again, ma'am.
Okay. Sir, eigenvalue, what does it mean, sir? Eigenvalue.
Eigenvalue is not needed, ma'am. Not needed, ma'am. For example, SPSS will give a lot of unimportant information also. Eigenvalue is not much important for this interpretation. Just leave it. Factor analysis only we are going to discuss. Eigenvalue.
Okay. Thank you, sir.
Okay. participant? Have you all come? Are you there?
Yes, sir.
Shall we proceed? We have limited time. We have another 15 minutes to go. I'll give you some introduction and I will demonstrate the analysis we conduct tomorrow. Tomorrow we have only two topics, factor analysis and cluster analysis. Simple one. So I'll give you the application of binary logistic regression, when to use it, how to use it, the assumptions. Then I will demonstrate the steps. Analysis we do it tomorrow. Otherwise, I will demonstrate one application, one example, and we can conclude today's session. Tomorrow we continue the binary logistic regression. Another example, one or two another example. So the concept of binary logistic regression, the regression technique we studied earlier, is used to assess the strength of a relationship between one dependent and one independent or multiple independent variable. So regression analysis used to help in predicting a value of dependent variable from one or more independent variable. You have one independent, one dependent, we call them simple linear regression. When you have one dependent and multiple independent variable, we call them as a multiple regression. So regression analysis helps in predicting how much variance is being accounted in a single response, the dependent variable, by a set of independent variables. This is what we studied in regression. So linear regression analysis requires the outcome criterion variable to be measured as a continuous variable. However, there may be a situation when the researcher would like to predict an outcome that is dichotomous or binary, yes or no, pass or failure, male or female, success or failure, whether you go to interview, whether you may get the interview or you may not get the interview, successful interview. Our candidate will have a disease or may not have the disease. We can predict. So you have a couple of independent variable or numeric or some are categorical. Your outcome variable, the results is only dichotomous, yes or no, pass or failure kind of thing. So how we can run for this kind of scenario, we call them as a binary logistic regression. So in this situation, a scholar can use binary logistic regression to assess the impact of one or more predictor variable on the outcome variable, on the dependent variable. The dependent variable is a dichotomous. Outcome is only two possibility. So the logistic regression predict a group membership. Logistic regression calculate the probability of success over the probability of failure. Pass in the exam or failure in the exam, or having the disease or do not have the disease. We can predict. The results of analysis are in the form of an odds ratio. Logistic regression determines the impact of multiple independent variables presented simultaneously to predict the membership of one or other of the two dependent variable categories. I'll give you one or two simple examples. So to predict the dependent categorical variable based on one or more independent variable, independent variable, there are different types possible. Can be numeric, can be continuous, can be ratio, can be interval, or kind of ordinal, or can be what you call nominal. So binomial logistic regression, often referred to as a simply, we call them as a logistic regression. Predict the probability that an observation fall into any one of the two categories of the dichotomous dependent variable based on one or more independent variable that can be either continuous or that can be categorical, nominal or ordinal scale. So independent variable, imagine that categorical means when you have one independent variable, we call them as a simple logistic regression. The dependent variable is categorical. When you have one independent variable, we call them simple logistic regression. Suppose you have one categorical variable, also we call them as a simple logistic regression. Suppose you have more than two independent variable, and you have one dependent variable with category. So we call them as a multiple logistic regression. So your independent variable also can be numeric or categorical or mix. gender and age on what you call predicting the hypercholesterol, for example. So how do you write the hypothesis? To predict the dependent variable based on one or more independent variable, depends upon the type of the variables. We can write the hypothesis for logistic regression. Null hypothesis, your dependent variable does not depend on any one of the independent factors or independent variable. Meaning your dependent variable outcome is not depending on the any one of the independent variable. So alternate hypothesis, we can state your dependent variable, outcome variable, depending on at least any one of the independent variable. Not all of them, at least one of the independent variable influences your dependent variable. Have you all understood? Have you all understood? The example, what are the scenario? I'll give you easy. Any researcher may utilize binary logistic regression, the following situation. For example, in a supermarket, when you go to supermarket, nowadays they will ask your phone number. Sometimes they collect a membership. They will ask your membership, where you work, what is your income, your family size, they may ask you. So based on that information and the quantity of the purchase you have done for every month, they will predict whether you come back to the same store, your next visit, whether you come or you do not come. So this kind of scenario, whether you come to the bank or you do not come to the particular store, they can predict. Or what you call a good customer or bad customer, we can predict based on your income. For giving you loan, we can also go for logistic regression, whether the candidate will be able to repay the loan or cannot able to repay the loan, can predict whether the candidate is a good based on the age, based on the income, based on the working area, based on the family size, or is there any loan. We can predict whether the candidate is a good candidate, will be able to repay the loan or may not be able to repay the loan. We can predict using binary logistic regression based on the previous data. So then a college students would like to assess admission, college admission based on the student age, grade, aptitude test results, whether the candidate is based on this attribute, whether the candidate can be admitted into the college or into the school or not admitted into the school, we can predict. So assess if a particular candidate win or lose in the election based on the time he spent in the constituency, or previously elected, a number of issues has been resolved for the last 5 years. Based on that, whether the candidate will win or may not win, we can predict. Based on the performance of the last 5 years, how much he has contributed, how much time he spent, how many times he has been elected, how many issue has been resolved, can be assessed whether the candidate, the next election, whether he may win or he may lose. We can predict. Or in a HR, human resource related researcher, would like to ascertain how factors like experience, years of education, and the previous salary, university ranking affect the selection of a candidate in a job interview. So, is the number of years of experience, years of education, the salary level, and the university ranking the candidate has come from, the success in the job interview, we can predict. So your dependent variable, job interview, successful, not successful. The independent variable are experience, years of education, salary, university ranking, or independent variable. So how does the independent variable influences to successful in an interview or not successful in an interview? So outcome is a interview outcome is a yes or no, successful or not successful. Another example, a scholar would like to predict choice of bank, public bank or private bank to choose. Public bank or private bank to choose for availing loan or some other kind of thing, having an account. So how do you choose? Actually, there are several factors: the technology, interest rate, value-added services, perceived risk, reputation, and others. So these all, the red colored one, are independent variable. Choosing the bank, public or private, is a dependent variable. So this scenario, we can go for a binomial logistic regression. So I'll give you one simple example. Simple example so that we can finish it today. And tomorrow we go for multiple logistic regression. One objective of the study, identify the risk factors. Effect of age, otherwise impact of age, gender, diabetes, hypertension, and exercise on hypercholesteremia. How does age, male or female, the candidate having diabetes and also hypertension, and he has been whether number of hours he do exercise, and then predicting whether the candidate is hypercholesterol or not in the cholesterol range. So please open the file. You will have this window. Maybe we can open the file. Hypercholesterol 2.51. Please open the file 2.51. So I'm going to go only one simple example, simple linear regression. Sorry, simple binary logistic regression. Effect of age on the hypercholesterol. 1 year age increases, how much risk being a hypercholesterol. Okay. Please open the file. I'm going to see the impact of age on the hypercholesterol. So anything less than 6.2, not cholesterol. Anything more than that, the candidate is a hypercholesterol. So we are provided with impact of age on hypercholesterol. Impact of age on hypercholesterol. So 0 means not hypercholesterol. Anything more than 1 means that is a cholesterol. So this candidate or hypercholesterol. So anything the borderline 6.2 and above, the candidate are hypercholesterol. Anything less than that, no hypercholesterol. There are 2 categories. So 1 year age increases how much the risk the being into hypercholesterol. Shall we go for it? Shall we go for it? So go to analyze. Participant, do you all with me?
Yes, sir.
Yes, sir.
Yes, go to analyze.
Yes, sir. Yes.
Regression. Binary logistic. Regression binary logistic. So if you have 1 or 2 examples, you can understand the concept of the application of binary logistic regression. I have a couple of exercises. Today I will demonstrate one, and tomorrow we can cover the rest of the examples. So click on binary logistic. We all have this window.
Yes, sir.
We all have this window. The last variable hypercholesterol.
Yes,
So
We'll go to dependent.
By asking the age, we will be able to predict whether the candidate will be hypercholesterol or may not be. Depends. Okay. So transfer your hypercholesterol dependent. Age, you keep it in the covariate. Effect of age on hypercholesterol, we are going to go. Impact of age on hypercholesterol. Simple example. So this is simple binary logistic regression, not multi. Simple binary logistic regression. Why? We have 1 independent, 1 dependent. 1 independent variable.
Can't hear you, sir.
Yeah, I think some technical issues are there, I think.
Is there, but we can't hear.
Hello,
Yeah.
can you all hear me? Some difficulty is the internet.
Yes, sir.
Now we
So
yes, sir.
have you all transfer your dependent and independent?
Yes, sir.
Yes, sir.
Okay.
Yes, sir. Yes, sir.
Dependent hypercholesterol, your independent age. Click on option. You click classification plot, Hosmer, Lame-Shoe, goodness of it, that first 2. You also can click confidence interval for exponential. Confidence interval for exponential. These 3 things we need to. So 1, 2, then 3. Have you all
Continue.
done? Then continue.
Yes, sir.
You don't need to do any other changes. No need to do any other changes. Click OK. Click OK. You will get the simple output. So before we move on, we also need to know the average age of the two group of people. Less than 6.2, what is the average age? More than 6.3, what is the average age of the group of people? Two group of people we have, but we are interested in their descriptive statistics. So the results show that 144 candidate, they were less than 6.2. 56 candidate in the study are more than 6.3. 6.3. So exponential is this. Exponential is this. So what does it say? Sorry, we have to go for variables in the equation, not the previous one. Sorry, we have to go to this particular table. Variables in the equation, very, very important. Don't go for the previous table. We should not go for it. Classification table, variables in the equation, we should not go for it. The first step, we have to go for the enter method, second one. The last table. Last table. And also the classification table also very important. So it says that the system correctly classified, meaning 134 candidate, they are less than 2. 134 candidate less than 2, correctly predicted. And
Hello, sir.
Yep, please, ma'am.
Your screen is not moving, sir.
Participant, is it moving or not?
Yes, sir, moving.
Moving. Maybe your system,
Moving, sir.
Maybe your internet, ma'am, your side. Maybe your side.
Okay. Yes,
so, how do we interpret these results? What actually SPSS will give you a lot of information.
Sir, can you once again repeat it, because classification table? Let me check, sir. Where is the classification table? Yeah, in our classification table we have got less than 6.2 is 144, more than 6.3 is 56.
Go to the last table, sir. Last table, sir. The last table before the variables in the equation.
Yes. Okay, sir.
So this classification table is very, very important, meaning how the system classified 74% accuracy. 74% accuracy, meaning from age, how accurately it predicts. The first one we can call them as a sensitivity. The second one we call them as a specificity. I'll come back to you. The sensitivity, specificity takes little time. Tomorrow I will elaborate. So 74% the system predict correctly, meaning if he is less than 6.2 means less than 6.2, the system predicts. If anything more than 6.3 means 42 candidate more than 14 candidate 6.2. It predicts exactly. So 74% correctly predicted. If anyone less than 6.2, less than 2 predicted. Anyone more than 6.3, 74% of the prediction is accurate prediction. 74. Remaining 26. Anything more than 70 is well and good. Okay. So how do we interpret the variables in the equation? So this interpretation, maybe you can copy this table. Maybe I'll go to the results, will be easy for you to understand. So this is the table. From this table, how do we interpret? What information we need to draw? So how does age influences being into hypercholesterol, not into hypercholesterol? Yes, age influences. So increasing age, there is an increasing possibility of being into hypercholesterol or not into the cholesterol significantly, meaning age influences significantly, the p-value. How much influences? An increase in 1 year age has a 1.21 times more likely of having hypercholesterol. For example, your age is 31, someone is 30. Your age is 31, someone age is 30. So you have 31 years, you have 1.21 times more likely of having hypercholesterol compared to your 30 years old friend. Suppose your age is 35, your friend age is 34. So you are having more risk, 1.21 time more likely of having a hypercholesterol when compared to your friend who is age is 34. Understood? So 1 unit of your age increases, this much more likely of having being into the hypercholesterol. So this sentence we need to write like this. Suppose anything the exponential lower than this, meaning age does not influences what you call being into hypercholesterol. So anything more than 1 positively, anything less than 1 negatively. Lower risk ratio. Anything more than means anything more than 1 odds ratio, higher risk. Anything lower than 1 is a lower risk. 1 year age increases, this much the reduced risk of being into hypercholesterol. So this case positively higher risk. So 1 year age increases, 1.28 unit of more likely of you will be into hypercholesterol when compared to 1 year younger than you. So how does it possible? How does this particular result is valid? When you repeat the study for 100 times or 90 times, sorry, 100 times, 95% of the time, your likelihood ratio from this particular range, 1.12 to 1.30, 95 times. 5 times when you repeat the study, conduct the similar study in the population, your exponential can go or away from the lower and upper boundary. Agree? So how do you summarize it in the result section? How do you summarize these results in your table? First of all, we need to calculate the average age of the less than 6.2 and then average age of the candidate more than 6.3, the cholesterol. And then we need to capture the odds ratio, 1.21. This is what? This value, odds ratio. We need to capture. And also we need to capture this, the confidence interval. And then we need to capture the p-value, this p-value, like this. Understood? Understood? Shall we calculate the age, average age and standard deviation of these people? How do you do? Shall we calculate? Go to the file. We are interested in hypercholesterol and age. We are going to calculate the average age of less than hypercholesterol and more than hypercholesterol. How do we? Go to analyze. Go to analyze. Explore. Explore. They are with me?
Yes, sir.
Another
Yes.
explore. So dependent variable. This time age. We are going to calculate the descriptive statistics. That's what I'm going. We are going to other way around. So hypercholesterol is a factor. Age in the dependent, hypercholesterol is a factor. Go to statistics. Click on statistics. Just click descriptives. You'll come to know the mean of less than 6.2 and more than 6.3 and the standard deviation of 6.2 and more than 6.3. Continue and click OK. Age in the dependent, hypercholesterol in the factor list, click OK. Can you see here the mean of less than 6.2 is 38.131. Standard deviation is 4.834. And more than 6.3, the mean age is 42.59. Standard deviation is 4.686. This value we have captured in the table. Participant, have you all done? Have you all got the value?
Yes, sir.
The descriptive statistics. So the mean value we need to be
Yes, sir.
captured in this particular. So 38.3, the standard deviation of less than. Maybe you also can capture the number of candidate also, nothing wrong in that frequency. How many are less than 6.2? How many are more than 6.3 also can be captured. Additional, if you are interested in one more column, you can keep it. So this is a table we need to capture for a simple study. You have one independent, one dependent. The dependent is a dichotomous. You can summarize your results like this. I hope you have understood. I hope you have understood.
Yes, sir.
Yes, sir.
And the inference can be written like this.
Sir, in in a case like if we have one independent variable we have one independent variable and three dependent variables. So if we wanted to study the impact of the independent variable on each dependent variable, we can do 3 times, no?
Yes, ma'am. You can do ANOVA.
Okay, we can do ANOVA, but can we run this also, one by one with one independent variable and one dependent variable? Is it?
What is your objective, ma'am? You mentioned that you have 3 dependent, right? Agree with.
Yeah.
But please tell me, all the dependent variable is going to predict or estimating the independent?
Yes, sir.
So give an example of study, ma'am. What is your
Sir,
nature of your dependent?
for example, if I say the research question, how much trainings impact on the productivity of the employees or employee engagement and job satisfaction? So
Okay,
how we can take
so
this?
training is it a numeric? What is your training? How do you, what kind of training?
Training is on a Likert scale. It is
Likert
on
scale.
the question.
How many group?
Yes.
How many group?
It is 3 groups.
3 groups. Okay, then you can go for effect of training on the satisfaction. Effect of training on.
So we can do 3. We can run twice.
3
3
times
times.
ANOVA. 3 times ANOVA.
3 times ANOVA. Okay.
Yes, yes, ma'am. Yes, ma'am.
Okay.
If you have a categorical, your training is a categorical or group 3 groups, you can run ANOVA. Okay. So if you have any difficulty, you also can send me your data. I'll help you out, ma'am.
Thank you so very
If
much.
there is any this thing, you can also forward me your data. I will.
Sure,
Yeah.
I appreciate. Thank you so much.
Thank you. Thank you. We'll see you tomorrow. We can discuss some more the binomial logistic regression and multinomial logistic regression tomorrow. And tomorrow we are going to discuss. Yes.
Yeah. So yesterday you said you send the this PDF of this class.
Okay.
Have you sent it or you will be sending?
Already there, sir, in the folder. This is what I sent you the folder,
okay,
sir.
Oh, I did not see it. Okay.
There is in that folder there is a one PDF file. The last one, ASBM University July. The last one.
Hello.
It is there.
Hello.
Yes,
good evening, sir.
Yes, sir. Got it. Yes, sir.
Good evening, sir.
Good evening, sir. Sir, I have a problem. Would I send a mail to you?
Yeah, email me, sir. I will give you my email.
Yes, sir.
Okay, if there is an issue, then yeah, I will. Do you have my email?
Yes, sir. I will check on the PDF you have sent.
Yes, it is there. My email. Yeah, please.
Yes, sir. In the top of this, I think you have mentioned.
This email, sir.
Yes, sir.
And this is my WhatsApp number.
GNCEXL, sir.
GNCXL@gmail.com.
Yes, this is your sir mail.
This is my email, sir. This is my email, my destination, my contact number.
Ji, sir. Thank you, sir.
Okay, so you can contact me through WhatsApp or you can contact me through this email. Thank you.
Ji, sir. So thank you.
Thank you. We'll see you tomorrow. Thank you.
Thank you, sir. Thank you.
Thank you.
Thank you, sir.
Thank you.
Thank you very much, sir.
Thank
you
you
all the.
Thank you, everyone.
Thank you.